In this video, we're going to answer some questions related to solubility curves. On the y-axis, we have the solubility, and on the x-axis, the temperature in Celsius. On the y-axis is the grams of solute dissolved per 100 milliliters of water. Now, some solubility curve worksheets might have grams of solute per 100 grams of water, which is the same thing. 1 milliliter of water is equal to 1 gram of water because the density of water is 1 gram per milliliter. So let's start with number 1. How many grams of KCl can be dissolved in 100 grams of water at 40 degrees Celsius? So we need to identify the KCl line, which is here. And at 40 degrees Celsius, we need to locate the value on the y-axis. We could dissolve 40 grams. So that's the answer to the first part of the question. We can dissolve 40 grams of potassium chloride per 100 grams of water, which is equivalent to 100 milliliters of water. Now, what about the second part? How many grams of KCl can be dissolved in 250 grams of water at 40 degrees Celsius? Well, we know that 40 grams can be dissolved in 100 grams of water. So if we want to find out how much can be dissolved in 250 grams of water at that same temperature, we need to set up a proportion. So let's cross multiply. So this is going to be x times 100, or 100x, and that's equal to 250 times 40, which is 10,000. So 10,000 divided by 100 is 100. So let's make sense of this. So 40 grams of KCl can be dissolved in 100 grams of water. Now, if we increase the quantity of water, we can dissolve more stuff in it. So we're increasing the amount of water by 2.5 times the original value. 100 times 2.5 is 250. So 40 times 2.5 is 100. So we could dissolve 100 grams of KCl in 250 grams of water. So if you increase the volume of water, you can increase the mass of the solute that can be dissolved in water. Now let's move on to our second question. Which compound is least soluble at 30 degrees Celsius? So let's draw a line at 30 degrees Celsius, which is here. So the compound that is least soluble is going to be the one that's lowest on that line, which is the green line. So therefore, cerium sulfate is the least soluble at 30 degrees Celsius. Now, which compound is the most soluble at that temperature? Out of everything that's listed in this graph, the highest one is the red line. So potassium nitrate is the most soluble substance at that temperature using the graph that we're given. Number 3, at what temperature will the solubility of potassium nitrate and potassium chloride be the same? By the way, for each of these problems, feel free to pause the video if you want to try it yourself. I think it's good to try it yourself and then see if you get the answer right. Potassium nitrate is the red line, potassium chloride is the blue line. To find out when the solubility will be the same, we need to look at the point of intersection, which is here. And we're looking for the temperature that corresponds to that solubility. So that's at 20 degrees Celsius. At 20 degrees Celsius, the solubility of those two substances will be the same. Now, what about the second part of the problem? At what temperature will the solubility of KNO3, the red line, and cerium sulfate, the green line, will be the same? So look for the point of intersection between the red line and the green line. So that's a temperature that's between 0 and 10. It's very close to 0, so we could say like maybe it's 1 degree Celsius or 2 degrees Celsius. Based on the graph, we can't get an exact number, so all we could do is estimate the temperature. Number 4, at what temperature will 50 grams of potassium nitrate dissolve in 100 milliliters of water? So potassium nitrate is the red line, and we're given the solubility, it's 50. So we got to find the x value that correlates to this point. So let's go down along the x-axis. So the temperature is approximately 30 degrees Celsius. At that temperature, we could dissolve 50 grams of potassium nitrate in 100 milliliters of water. Now let's move on to the second part of the problem. At what temperature will 50 grams of KCl dissolve in 100 milliliters of water? So we're dealing with the blue line. So we're starting with 50 again. And let's keep drawing the line until we reach the blue line, which is somewhere in this region. So the temperature is approximately 60 degrees Celsius. May not be exact, but we're just going to use a rounded answer. So at 60 degrees Celsius, we could dissolve 50 grams of potassium chloride in 100 milliliters of water. Number 5. Which substance is most affected by temperature changes? Is it potassium nitrate, potassium chloride, or cerium sulfate? The answer is potassium nitrate. The slope of this line is extremely large. So potassium nitrate is most affected by temperature changes. Cerium sulfate is least affected by temperature changes, especially above 20 degrees Celsius. So whenever you need to find which substance is most affected by temperature changes, you're looking for the line that is most vertical. So this is the one that's most affected. It's the line with the highest slope. So M, which represents the slope in algebra, is extremely large. Now, the substance that is least affected by temperature changes on a test, you're looking for the line that is horizontal. You want the slope to be 0. So that means it's unaffected by temperature changes. Number 6. At 40 degrees Celsius, what volume of water is needed to dissolve 175 grams of potassium nitrate? So let's focus on the red line. So we're dealing with 40 degrees Celsius, so it is wise to calculate the solubility at this temperature. So the solubility approximately is 70 grams. So let me go ahead and write that. So at 40 degrees Celsius, we can dissolve 70 grams of KNO3 per 100 milliliters of water. So we're looking for the volume of water to dissolve 175. So what we can do is set up a proportion again. So let's get rid of this. And let's solve for x. So first we have 175 times 100. And so that's 17,500. And then that's equal to 70 times x, or 70x. So x is going to be 17,500 divided by 70, which is 250 milliliters. So in 100 milliliters of water, we can dissolve 70 grams of KNO3. Now, if we increase the volume to 250, we can dissolve 175. Another way you could do this is looking at the ratio between the 175 grams of KNO3 and the 70 grams of KNO3. So 175 divided by 70 is 2.5. So we want to increase the amount of KNO3 that we can dissolve by a factor of 2.5. So then you multiply this number by 2.5 and you'll get 250. So there's many different ways in which you can do this. Now go ahead and try the second part of the problem. It's very similar to the first part. So at 30 degrees Celsius, what volume of water is needed to dissolve 280 grams of KCl? So here's the line at 30 degrees Celsius. and it corresponds to a solubility of 35. So we need to set up another proportion just like before. So if 35 grams of KCl can dissolve in 100 milliliters of water at 30 degrees Celsius, then how many milliliters of water do we need in order to dissolve 280 grams of KCl at 30 degrees Celsius? So cross multiplying again, this is going to be 280 times 100, which is 28,000, and that's equal to 35 times x. So it's 28,000 divided by 35. You have to divide both sides by 35 to get x. And so that's going to be 800 milliliters. So if you take 280 and divide it by 35, we needed to increase the mass of KCl by a factor of 8. So 100 times 8 will give you 800. So now you know how to determine the volume of water that you need to dissolve a certain amount of substance at any given temperature. Number 7, determine if each solution is saturated, unsaturated, or supersaturated. Now recall that maybe if you saw another video that I created on solubility, it's a basic introduction on that video. I mentioned that whenever the concentration is less than the solubility, then you have an unsaturated solution. That means you can dissolve more. So this favors dissolution. Whenever the concentration is equal to the solubility, then you have a saturated solution, which is in equilibrium between the aqueous phase and the solid phase. And whenever the concentration is greater than the solubility, you have a supersaturated solution. This favors precipitation. If you add a seed crystal, it can crystallize the whole solution. Concentration tells you how much stuff you have in the solution per 100 milliliters of water. Solubility tells you the most that you could dissolve at a given temperature. So concentration could be many values, however there's only one solubility value at a given temperature. Now, it's important to understand that these values represent how much is already dissolved in the solution and not how much you're trying to put in the solution. It's important for some of these parts in this problem. So in part A, we already have 20 grams of potassium nitrate dissolved in 100 milliliters of water at 30 degrees Celsius. So this solution that we already have, is it saturated, unsaturated, or supersaturated? So let's compare concentration and solubility. The concentration of this solution is 20 grams per 100 milliliters. And since the volume is the same, I'm just going to compare the masses. So the concentration is 20. The solubility, we got to find out what that is. So KNO3 is the red line, and at 30 degrees Celsius, that's going to correspond to a solubility of approximately 50. Now another way you can look at it is you can look at 20 relative to the red line. So at 30, 20 is over here. Notice that it's below the red line. So that tells you that we have an unsaturated solution. And also, C is less than S. So you can look at it two ways. You can compare C and S, or you can look at 20 relative to the red line. If it's below the red line, it's unsaturated. If it's at the red line, it's saturated. And if it's above the red line, it's supersaturated. So there's two ways in which you can determine the saturation of the solution. So the solution in part A is unsaturated. Now let's move on to part B. So at 40 degrees Celsius, we're dealing with KCl, which is the blue line. The concentration is 40, and notice that it matches with the solubility. So C and S are 40. So C is equal to S. Therefore, we have a saturated solution. Now let's move on to part C. So the concentration is 30 grams. Now I didn't put a volume, but let's assume that it's per 100 milliliters. I forgot to put that. Now at 50 degrees Celsius, notice that the solubility is less than 10. We could say maybe it's like 7. So notice that the concentration is greater than the solubility. If you plot 30 at 50 degrees Celsius, it would be here. So that's the concentration. Notice that it's above the green line. So that tells us that we have a supersaturated solution. Now let's move on to part D. Now we have 15 grams of potassium nitrate, the red line, in 25 milliliters at 30 degrees Celsius. So we can't use this value yet because the volume doesn't match. So we need to see how much this would be if we had 100 milliliters. So 15 grams of potassium nitrate, which corresponds to 25 milliliters, we need to see how many grams of potassium nitrate correspond to 100 milliliters. So notice that we need to increase the volume by a factor of 4. So 100 divided by 25 is 4. So therefore we have to increase the mass by 4. So 15 times 4 is 60. So it should be 60 grams per KNO3. But if you want to do the work, it's 25x, which is equal to 15 times 100, that's 1500. And then take 1500 divided by 25. So x is 60. So therefore the concentration is 60 grams of potassium nitrate per 100 milliliters of water. So at 30 Celsius, we need to look for the red line. The solubility is 50. So the concentration is greater than the solubility. So at 30 Celsius, the concentration is 60, but the solubility is 50, so it's above the red line. Therefore, we have a supersaturated solution for part D. And so that's it for that problem. Number 8. If 15 grams of KNO3 is dissolved in 200 milliliters of water at 20 degrees Celsius, how many additional grams of potassium nitrate is needed to make the solution saturated at 40 degrees Celsius? So, what do we need to do in this problem? This is the last question, so feel free to try it. We need to find the solubility at 20 and at 40. So at 20, the solubility of KNO3 is about 30. So let's write that. 20 degrees Celsius, the solubility is 30 grams per 100 milliliters. Now at 40 degrees Celsius, the solubility is much higher. So it's about 70. So it's 70 grams per 100 milliliters. Now the volume is 200 milliliters. That's how much we have in whatever the container is, either a beaker or something. So if we double the volume of water, the mass of solute that we can dissolve at that temperature should double. So if we could dissolve 70 grams of solute in 100 milliliters of water, then we could dissolve 140 grams of solute in 200 milliliters of water. If you double the volume, you could double the mass of solute that can be dissolved at that temperature. So right now we only have 15 grams of potassium nitrate dissolved in 200 milliliters of water at 20 Celsius, which is much less than the solubility. So initially we have an unsaturated solution. However, we want to make a saturated solution. So when we raise the temperature to 40, we can dissolve up to 140 grams in this volume in 200 milliliters of water. So right now we only have 15 grams in 200 milliliters of water. That's how much is already in the solution. But to make a saturated solution, we need to get up to 140 grams in this volume of water. So 140 minus 15 is 125. So we need an additional 125 grams of potassium nitrate at 40 degrees Celsius. That's how much we've got to add at that temperature in order to make it saturated with a volume of 200 milliliters. So the answer is 125 grams.